All right, good morning and welcome back. I hope you guys had a great spring break. Today we are going to start our next chapter, chapter 6, and it's talking about polygons. So our polygon is some sort of closed figure that has straight sides. And we have a couple different types of polygons. Now, the first here, concave polygon. This is when we have a polygon and at least one interior angle is bigger than 180. Okay, so let me write that and then I'll show you what I mean by that. So at least one interior angle is bigger than, oops, misspelled that, bigger, ER, 180 degrees. Okay, so an example of that, what I mean, I'll draw this kind of off to the side. If we have here, so what I mean by an interior angle is on the inside. So like this one is roughly 90, maybe it's 88 or something. These all small, but then right here, you look, do you see that is bigger than 180? Okay, it is farther than a straight line. The small angle is on the exterior there. If that is the case, we call this concave. Think of it as like there's a cave in on the side. Okay, now the next one is convex, and this is when all the interior angles are less than 180. And an example of that, pretty much all your standard shapes, right? Your square, each one's 90, a triangle, those add up to 180, so they all are less. We could draw as many as we wanted here. Convex, just each angle on the inside is less than 180, okay? And then the final one here, regular polygon. This is when all the angles and sides are congruent, okay? So all the angles are the same, all the sides are the same. A square would be an example of a regular polygon. A rectangle would not. While all the angles are congruent, they're all 90, the sides are not all the same length. All right. Now, when we are finding the interior angles, what they all add up to. Remember, sum means adding up the interior angles here. And notice throughout these notes, if there's a star beside it, that means definitely write that down. Those are an important formula. So all we have to do is take 180 times whatever n minus 2 is. Okay, and in this case, n represents how many sides there are, which is also how many angles there are. Okay, so right here it says, what is the sum of the measures of the interior angles of a convex hexagon? Okay, so if we need to sum up the interior angles of a hexagon, we think about it, hexagon, that's a 6-sided figure. So all I have to do is 180 times whatever 6 minus 2 is. So that'll be 180 times 4. Now, if you are having trouble doing that in your head, that's fine. Just pull on your calculator. All right, so 180 times 4, and we get 720. Okay, so 720 degrees. Now, the next one, what is the sum of the measures of the interior angles of a convex 14gon? If it's a 14gon, that's a polygon with 14 sides. So same thing, 180 times whatever 14 minus 2 is, which in our case would be 180 times 12. Okay. Once again, I don't expect you to do this in your head. Just go 180 times 12. Hit enter. 2160 is what we get, or 2,160 degrees. Okay, now some of you might be thinking, well, why is it n minus 2? So if we look at this last question, it says using diagonals form a common vertex, or sorry, using diagonals from a common vertex, how many triangles could be formed from the polygon picture below? Okay, so we have our polygon here. We use a common vertex, meaning choose any point on the edge. So I'm going to choose this one. It says using diagonals, how many triangles could be formed? So I'm going to draw from that line. There's a side. I'll draw to this one. I'll draw that one. And if you think about it, I've formed 1, 2, 3, 4 triangles. I can't draw a line from here to this side because that is already there. It's already a side. And same over here. So if you think about it, we already know in each triangle the degrees are 180. And there were 6 sides, and when we drew it, we only got 4 triangles here. So that's why 6 minus 2 gives us that 4. Okay. Now, if we think about it, it's always going to be the case. This has 180 degrees in it. This has 180 degrees. This has 180. And so does this. So if we multiply by 4, we'll get our answer. And you could do that with any shape. Even if it wasn't, this one was regular, meaning all the sides and angles were the same. Even if it wasn't, you could easily draw these diagonals, find your triangles. Okay. So the next thing we're going to talk about is what if we are finding the measure of the specific interior angle of a regular polygon. Okay, so all we have to do in that case, it's the same formula. We just take 180 times n minus 2, except now we divide it by n. Okay, now I'm not quite sure why I wrote it like this, but on letter A, let's first acknowledge this is not a regular polygon. Probably should have had this one first, but on this one, it's not a regular polygon. But we know that all of these will add up to be whatever 180 times n minus 2 is. So we count our sides over here, 1, 2, 3, 4, 5 sides. Okay, so we can do 180 times 5 minus 2. So that's 180 times 3. So our total, oops, that's not a very good 5, but our total is 540 degrees. Okay, at this point, we can add all of these up. Now, I don't know what x is yet, but 120, 151, 56, and I know that square is 90. So if I add all those up, 120, 151, 56, also that 90, we'll get a 7 here, we'll get 21, 417. All we have to do then is take that 540 minus the 417, and whatever we get, that is what x equals. So in our case, x will equal then for us 123. Now on the next one, as you can see, these arcs tell us that each of these angles are the same. The little lines tell us each of the sides are the same. So if that's the case, it is a regular polygon. We can just use this formula. So 180 times, now we have 1, 2, 3, 4, 5 angles. And it doesn't matter if you count the angles or sides because they'll be the same. Whatever's easier for you to count. So that's 5 minus 2. We'll divide that by 5 because there are 5 different angles that interior, or the sum of the interior angles is divided between. And we know they're all the same. Now on top, it'll be 180 times 5 minus 2 is 3. Whatever we get, divided by 5. 180 times 3, we saw in the last one was 540. Divide that by 5, and we will get x equals 108. All right. So a couple more things we need to talk about. So these were interior angles, meaning inside of a triangle. Exterior angle, think the exit. This is on the outside of a triangle. And the sum of the exterior angles in a polygon will always total up to 360. Okay. If we think about why, we know that one rotation around a circle is 360. As we draw more and more of these exterior angles, if I would draw lots and lots and lots of lines, if I have a circle and then a little bit short of that, but it was like a polygon with side, there's going to be all these angles. They will also add up to 360, much like a circle. So we just know it's going to be 360. Now, the measure of each exterior angle of a regular polygon, if we have a regular polygon, to find each specific angle, we can take 360 divided by n, whatever the amount of sides is. As we know, like before, if it's regular polygon, all the sides and angles are congruent, so the exterior angles will be congruent as well. Now, if we look at this one, and we're asked to find x, all we have to do on these, it doesn't matter how many sides there are, because we know it will add up to 360, because each of these is an exterior angle. So I can sum all those up and set them equal to 360. So 137 plus 43 plus x plus 1 plus 4x minus 1 plus x. If I add all that up, I will get 360. Now, I can combine my like terms. 137.43 is 180. Plus 1, 181. Minus 1 is back to 180. I have 1x plus 4x plus x. That gives me 6x. That will equal 360. Subtract the 180. We're left with 6x equals 180. Divide, and we get x to equal 30. Your next one, same thing. Now this one, there is no exterior angle here. However, remember the exterior angle always forms a linear pair here, which means they'll add up to 180. So if this interior angle is 90, that means the exterior angle is also 90. So once again, I know they'll add to 360. I can do 2x minus 12 plus 32 plus 2x plus x plus 90. If I add all that up, I'll get 360. Combine our like terms. So 2x, 2x, and x gives us 5x. Negative 12 plus 32 is 20. Plus 90 would be plus 110. That all equals 360. Take away 110, we'll get 5x equals 250. Almost done. Just divide, and we get x equals 50. All right. On your next one, you are asked for x. On this case, it is a regular polygon. So even though we don't have all those other ones, we know if I would draw a line right here, that angle formed. What I mean by that is if I draw a line, this angle where I put the dot would be the same as that, because it's a regular polygon. They're all going to be the same. So if I count how many sides there are, 1, 2, 3, 4, 5, 6. I guess I counted the angles, but it's going to be the same either way. Okay, so we can just take 360 divided by that 6. And we know that x will equal 60 degrees. Likewise on D, I don't see what it looks like, but it says what's the measure of an exterior angle of the regular polygon has 18 sides. Key thing here, regular polygon. So I can do 360 divided by 18 because each of them will be the same. And that will give me 20 degrees. Okay, these final two, maybe are going to make us think a little bit more. This one, once again, we don't have a picture, but it says the measures of the exterior angles of a triangle are 2x, 6x, and 7x. So think about this. This is sort of like back when we were in the proportion channel or chapter. We're going to add those all up and then find what x is, and we'll know what the smallest exterior angle is. The only difference is when we were doing that, if they were interior angles, they add up to 180. Here it's going to add up to 360. Also, I forgot this would be a question mark. Okay, so 2x plus 6x plus 7x. If we add that all up, we're going to get 15x. So we just hit 15x equal to 360. Divide by 15. All right, at this point, if we divide that, we will get x to be 24. Now it says, what is the smallest exterior angle? The smallest one, 7, 6, 2 is clearly 2. So we plug that 24 in. 2 times 24 will give us 48 degrees. And the final one of today, final question of the day, once again, says the exterior angle, and it's a regular polygon, and it measures 72 degrees. How many sides does the polygon have? Now, if we think back up here, we said 360 divided by n will tell us what that exterior angle is of a regular polygon. So I can just do 360 over n equals 72. If you want, put 72 over 1 and then cross multiply. We'll get 360 equals 72n. Divide by 72. Divide by 72. And n will have to equal 5. So we have 5 sides. All right, that is all I have for today. If you need any help, please reach out. There is a Delta Math assignment, so please get that done. Hope you guys had a great break and a good first day back, and I'll see you guys soon. Bye.